But when evaluating security of cloud providers, it's very important to understand the distinction between the security measures that the cloud service provider implements and operates, which is known as the security of the cloud, and the security measures that the customer implements and operates, related to security of the customer content and applications that make use of the cloud service provider services. And this is called security in the cloud. Basically, the AWS shared responsibility model defines which security controls are yours and which are the responsibility of AWS. In other words, you decide the security for your applications that run in the cloud. For example, which ports are open, which IP addresses can access your resources, what patches are applied to the operating systems, do you have encryption enabled, etc. And AWS guarantees the global security of the AWS cloud, for example, the hardware, the data centers, the networks, etc. And this diagram here gives you an overview of who owns what. There are some exceptions to the AWS shared responsibility model. For example, with AWS managed services like RDS, DynamoDB, and Redshift, AWS is responsible for more than just the hardware and the networks. In these cases, AWS is responsible for the security configuration, like patching, antivirus, etc., and you're just responsible for account management and user access. Amazon Web Services takes cloud security and compliance extremely seriously. One of the biggest concerns of consumers is that the cloud is not secure, and it's something I hear time and time again. But in fact, that could not be further from the truth, as AWS invests huge resources into securing the AWS cloud and making sure that it's compliant with the required assurance programs. AWS Cloud Compliance allows customers to understand exactly what controls have been put in place by Amazon to maintain cloud security and data protection. However, AWS doesn't take full responsibility, as for systems that are built on top of AWS cloud infrastructure, the compliance responsibility belongs to the end user. AWS meets a large amount of the assurance programs for finance, healthcare, government, and many more. And here's a list of some of the assurance programs AWS is compliant with. And you can see there's some big names in there like HIPAA, FedRAMP, and ISO. But just because AWS have all these compliance assurance programs, it doesn't mean that your applications are compliant. There's still stuff you'll need to do with your applications to make them fully compliant with these programs. Let's start with infrastructure as a service. EC2, S3, and VPC are completely under customer control, so you have to perform all the security configuration and management tasks. The virtual instances are completely controlled by you. You have root access, AWS does not. AWS has no access rights to your instances or guest operating systems, and they cannot SSH or RDP into your servers, so they have no idea what's going on your instances. And you'll find this out if you ever raise a support ticket with AWS, that they are unable to log on to your instances to help you with your problems. You have to do screen sharing. So that's a security attribute that AWS provides. AWS has a storage decommissioning process that is designed to prevent customer data from being exposed to unauthorized individuals. Customer instances have no access to raw disk devices, and instead you're presented with virtualized disks. AWS proprietary disk virtualization layer automatically resets every block of storage used by the customer so that customer's data is never exposed to another. In a similar way, memory is also scrubbed by the hypervisor when it's unallocated from a host and is unavailable for use again until it is completely scrubbed. With the network, AWS protects against denial of service, man-in-the-middle, IP spoofing, port scanning, and packet sniffing. It prevents IP spoofing by AWS-controlled host-based firewall infrastructure, and it will not allow an instance to send traffic with a source IP address or MAC address other than its own. Denial of service is prevented through the use of security groups, access control lists, so that you can minimize public entry points and reduce the surface area of your applications. You can protect databases and non-internet facing resources in private subnets, and use Bastion servers for SSH and RDP access to instances hidden in private subnets. You can put your elastic load balancers in security groups with inbound and outbound restrictions. Amazon EC2 provides a firewall solution that by default is configured in Deny All mode, so you have to open up the ports you require for your applications to work. With network security, you can use HTTPS instead of HTTP, and you can use VPN to provide encrypted tunnel access to AWS. AWS allows you to perform vulnerability scans, but you have to request permission in advance to perform one, and you have to limit it to your own instances. And this is something you may see on the exam. It's a popular question. Are you able to run vulnerability scans? And the answer is yes, but only after you've got permission from Amazon. People often ask, is the Amazon corporate network segregated from the AWS network? And the answer is yes, using network security. Different instances running on the same physical machine are isolated from each other via the Xen hypervisor, which is what AWS uses. Also, the AWS firewall resides within the hypervisor layer, between the physical network interface and the instance's virtual interface. So all packets have to pass through this layer, meaning that any instances running alongside have no more access to that instance than any other host on the internet. Physical RAM is also separated using similar mechanisms. AWS provides multiple options to secure your user credentials. You have good old username and passwords, we have multi-factor authentication, then there's the access keys and the key pairs, and also X509 certificates. And these are a way of making media online secure by providing a certificate and a private key to a user, so that only the user with the key and the certificate can view the media that you've placed online. AWS provides the ability to encrypt with AES-256 encryption, so that data on EC2 instances or EBS storage is encrypted. For it to happen with low latency and to be efficient, it's only available on the more powerful instance types. AWS offers SSL termination on load balancers. So this means any traffic that passes between elastic load balancers and web servers is unencrypted, so the load is taken off them. So you can ensure that your data is fully encrypted all the way into Amazon, and then once it's in there, it can be unencrypted to speed up and make your applications work faster. Aws Direct Connect provides an alternative to using the internet to utilizing AWS cloud services. So in all the demonstrations we've been using, I've been connecting to AWS via my web browser. However, if you use Direct Connect, you can change this. So data that would have previously been transported over the internet can now be delivered through a private network connection between AWS and your data center or your corporate network. So it allows you to access public services such as S3 and private resources such as EC2 running within your VPC using your private IP space. It also means you can extend your IP address range of your office into your virtual private cloud. AWS Cloudtrail is a web service that records AWS API calls for your account and delivers log files to you. The recorded information includes the identity of the API caller, the time of the API call, the source IP address of the API caller, the request parameters, and the response elements returned by the AWS service. The AWS API call history produced by Cloudtrail enables security analysis, resource change tracking, and compliance auditing. Now, as you know, auditing is a hot topic in today's IT world, so enabling Cloudtrail to do this for you is very important. And you don't need to know much more about Cloudtrail other than what it's for and why you would use it. Amazon Cloudwatch is a monitoring service for AWS cloud resources and the applications you run on AWS. Cloudwatch enables monitoring for EC2 and other Amazon Cloud services, so you can get alerts when things go wrong. You can use Amazon Cloudwatch to collect and track metrics, so you can get system-wide visibility into resource utilization, application performance, and overall operational health. And you can use these insights to react and keep your applications running smoothly. Cloudwatch offers two types of monitoring. There's basic monitoring, which is included free of charge and polls every 5 minutes and gives you 10 metrics, 5 GB of data ingestion, and 5 GB of data storage. Then there's detailed monitoring, and this costs more. There's a price per instance per month, but it polls every minute, so if you want more detailed monitoring, then you can pay for it. AWS Cloudwatch allows you to record metrics for services such as EBS, EC2, Elastic Load Balancer, and Amazon S3. And using these metrics, you can add them to dashboards to give visual or text-based notifications of what's going on. And this is a diagram of a dashboard in Amazon Cloudwatch. Metrics are at the hypervisor level, so you can get things like CPU, disk, network, but you cannot see memory usage. Metrics appear as you add more resources to your AWS account. You can create events based on your Cloudwatch monitoring, for example triggering Lambda functions. So perhaps if your EBS volume fills up, you could trigger an event so that data is removed and archived from the volume, or a new volume is created. So there's many things you can do. You can install Cloudwatch Agents on EC2 instances, and this will send monitoring data about the instance to Cloudwatch. So you can monitor things like HTTP response codes in Apache, or you can count exceptions in application logs. You can set alarms to warn based on resource usage. For example, if CPU utilization is too high, then it could send a notification. It can also auto-scale, so if your CPU is maxed out, you can get another instance launched to take care of some of the load. Or you can send Cloudwatch monitoring alarms to EC2 actions to, say, recover an instance or reboot an instance if something happens. You can also use alarms to shut down instances. It isn't just used for starting them up. So if you have idle instances, you can get Cloudwatch to shut them down for you. In this demonstration, we're going to take a look at AWS Cloudwatch and how we can use it to shut down idle instances. So before I started this demonstration, I launched an Amazon Linux instance and let it run for 10 minutes, just so we'd have some data. So now I'm going to go to Management Tools and click on Cloudwatch. And this brings us to the Cloudwatch Dashboard. So what we're going to do is we're going to create a new dashboard, and we'll click on Create Dashboard so that we can have a look at the monitoring statistics for our new instance. So let's just give it a name and we'll call it just Simply Learn, just for a change. Okay, so it says Create Dashboard. And now we get the option, do we want to put text-based or metric graphs widgets to our dashboard? And we're going to select metric graphs. So we'll click on Configure, and then we're presented with all the Cloudwatch metrics that I have available in my AWS account. So obviously I've just launched an EC2 instance, so I'm going to click on EC2 metrics, and my new server is called Simply Learn Cloudwatch Demo. So I want to add CPU Utilization. So let's click on that. So let me create this widget, and then that now appears on our dashboard. So we can add more, so we click on Add Widget, we'll do another metric graph, we'll go another per instance metric, and let's choose network in and network out, and we'll create the widget. Now as you can see, there's not a lot happening here because I just launched this instance and I haven't really done anything on it. But this is how you would create a dashboard, and it's quite useful and very easy to see. So you can create a dashboard for your instance types. So what we're also going to do is set up an alarm. So let's go to Alarms. So now we want to create an alarm. So we click on Create Alarm, and we get to choose the metric we want to base the alarm on. Now obviously we have an EC2 instance, so we're going to choose that option. And we're going to do it based on CPU utilization of our Simply Learn Cloudwatch Demo instance. So we'll click on that and we'll click Next. So now we get to give our alarm a name. So just going to call it Simply Learn _alarm. Just for the purposes of this demo, we can give it a description, and now we get to set the alarm threshold. So we're saying whenever CPU utilization is, and we're going to say less than or equal to 50% for one consecutive period, and remember a period is 5 minutes in basic monitoring, we want this alarm to fire. So why would you do this? Well, imagine if you had a really high-powered server that you're using every night to do some highly intensive compute computations. So you might know that it runs for a couple of hours and it's charging you quite a lot of money per hour to run, but when the CPU utilization drops below, say, 50% or 10%, you know the job is complete. So then you can get an alarm to fire and an action to happen. So you could set a notification, so we could get it to send an email when this alarm fires. We're not going to do that in this demonstration, but we can do an EC2 action. So whenever this state is in alarm, I want it to stop this instance. So this instance is going to be stopped whenever the CPU utilization is less than 50% for 5 minutes. And it's just telling us that there. So now if I click on Create Alarm, and here is our alarm. So it's just so it's telling us we're in alarm already because this instance has been up and running. It has monitoring data for the last 5 minutes, and it's saying the alarm has fired. So let me click on it and we'll see why. It says state changed to alarm, reason threshold crossed. One data point, 0.0034, was less than or equal to the threshold of 50%. And it says when it's in alarm, it's going to stop the instance. So if we go to the EC2 dashboard, and here we can see that the Simplilearn Cloudwatch demo instance has been stopped, and it's in a status of alarm. So it's telling us that our alarm fired and it took it straight down. Now obviously that's a pretty dramatic example. You wouldn't expect anything like that to happen in a real world, but it's a good way of seeing how alarms work.